It's a beautiful day and a lovely day. Welcome to Mathematics Meal, a special program that is designed for special people like you, just to help all of us improve in the study of mathematics. Today on Mathematics Meal, we are going to continue with surds. Remember that in our previous video, we looked at the meaning of surd and types of surd. We also considered the basic rules in surd. So today we are going to look at the basic and non-basic forms of surd. It is very important that you watch the previous videos in case you did not watch them. It will help you to understand this aspect of surd. Remember that there is every need for you to subscribe to this YouTube channel, and if you are watching this video from Facebook, just like our Facebook page and also follow us on Facebook. Our Facebook page is Mathematics and Science Meal, and our YouTube channel is Mathematics Meal 1. Thank you. All right. Basic and non-basic forms of surd. That's what we want to dwell on today. Now, when is a surd said to be in basic form? That's the first question we need to answer. When? When can we say that a surd is in what? Is in basic form? Because when we know when a surd is in basic form, then we can now know how to express a surd in basic form. So we say a surd is said to be in basic form if the surd is written as, so when you write a surd in this form, where A is a whole number and B is a positive integer that is as small as possible. So whenever we write a surd in this form generally, such that A is a whole number and B is a positive integer that is very, very small. In other words, it can no longer be reduced. Once a surd is written in that form, that surd is said to be in basic form. For example, if I have 5 root 3, this surd now is in basic form because 5 is a whole number and 3 is a positive integer that cannot be reduced further. You cannot split 3 again. So you can't reduce 3 any further. So this particular surd is in basic what? In basic form. So once you have a surd written in this form, such that A here, in this case now, A is 5 and B is 3. So that what we have here is a whole number, and the number under the root sign is a positive integer that cannot be reduced any further. That means it is as small as possible. So we gave some examples of a basic form of surd. This in basic form, 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 and so on. Now, it means that when a surd is not written in this form, that surd is not in basic what? In basic form. Once you have a surd and it is not in this form, once a surd still contains a number that can still be reduced, then that surd is not in basic form. So for these ones, the numbers we have here, they are as small as possible. We cannot reduce them any further. So by the time we now begin to see how we can express a surd in basic form, we'll now understand what we mean by the number being as small as what? As possible. That's the number B. All right. Now, let's look at the steps. How can we now express a surd in basic form? How can we express a surd in basic form? Because in mathematics, one of the reasons for failing mathematics is not knowing how. You must know what you are asked to do, and then you must know how to do it. So if you know what you are asked to do, but you don't know how to do it, then you cannot actually execute the task. So you must know what you are asked to do in mathematics, and then you must know the steps, the laws, or the formula that can be used in doing what you are asked to do. So there is need for us to know the steps involved in expressing surds in basic form. Now we know when a surd is in basic form. That's the first thing. Then the next thing we need to consider is how can we now place a form or change a form, a surd rather, to basic what? To basic form. So we have few steps, about 5 steps. So we say take note of the surd and list the pairs of numbers that their product will give the number in the root sign. So it will be better for us to use examples as we are following these steps. So let's take a question on basic form of surd. So work examples. So let's say examples. You can say express the following. Express the following surds in basic form. Express the following surds in basic form. Okay, let's take the first one. We have square root of 24. Okay, now we'll say for us to express a surd in basic form, we take these steps. Take note of the surd, so the surd given to us, that's the surd. We have taken note of it, and list pairs of numbers that their product will give what? The number in the what? In the root sign. So we have taken note of this. Then we find numbers that when we multiply them, we are going to have 24. So what are the numbers that we multiply to obtain 24? 1 is 1 times 24, 2 times 12, 3 times 8, or 4 times 6. Okay, these are the set of numbers that their product, pairs of numbers that their product will give us 24. Okay, so listing these numbers is number one. Then the second thing is, which of these pairs of numbers are we going to do what? Select at the end of the day. So they say from the pair, select the pair that contains the highest perfect square. Remember that a perfect square is a number whose square root is a whole number. And from here, we only have this and this as the ones that contains perfect square. 1 is a perfect square, because the square root of 1 is actually 1. 4 is also a perfect square. So we are going to either select this or this. But let's go back to the step again. It says from the pair, select the pair that contains the highest perfect square. So here 4 is bigger or larger than what? 1. So 4 is larger than 1. So we are going to select this pair, not this pair, because this particular pair contains the highest, a higher perfect square, because we only have 2, a higher perfect square. So we're going to select this. So we'll select this. All right, we have selected. Use the selected pair to replace the number in the surd. So we use this pair to replace the number in the surd. So instead of having 24, we are using these 2, 4 times 6 to replace this number. Anyway, we did not change anything, because 4 times 6 is still what? 24. So we use it to replace the number in the surd. So separate them by multiplication. You remembered our basic rules in surd. That's why it's important that you watch our previous videos. Remember that according to the rules in surd, this times this is the same thing as saying m more times n. So if I have root m more times root n, is same thing as this. That means this can go back to this form, and if I have this, I can still write it like this. So I have this now, I can split it into this. That's what they asked us to do in this in that step there. So separate them by multiplication. So we now have root 4 times root 6. We separate them. Finally, find the square root of the perfect square and use it to multiply the radical to obtain your answer. So what's the square root of 4? Is 2 times square root of 6. This is not a perfect square. 4 is a perfect square. So when 2 multiplies this radical with 6, we are going to have 2 root 6. So you now see that Square root of 24, that's 24, is something as 2 root 6 in basic form. You now see, this is the basic form. This A now is 2, and B here now, in this case now, is 6. And you cannot reduce 6 any further because there's no other perfect square that you can obtain from here apart from 1. And 1 times 6 is still 1. Sorry, it's still 6. All right. We take a second question. Maybe by the time we solve the second problem now, the principle, you begin to master this principle. Let's take another one. Let's say I have square root of 48. Square root of 48. Okay? Square root of 48. That's our solution here. You want to express square root of 48 in basic what? In basic form. All right. Let's begin the journey again in stepwise form. You remember, there is not every topic in mathematics that involve formula. There are some that you want to solve, you use laws. There are some when you want to solve some mathematical problems, you use steps. So in this case, we have steps that we must follow in order to express a surd in basic form. Just like you are preparing your soup, they say add water, add oil, add maggi, add this one, add the other one. So the same way. So if you can prepare soup, definitely you're supposed to be a good mathematician. Sorry, don't mind me. Let's look at this. All right. We look at this. We say it. Take note of the surd. We have taken note of that. We have surd 48. That's root 48. And then list pairs of numbers that their product will give a number in the root sign. So what are the numbers we will multiply to have what? 48. Let's get the numbers. We're going to have 2 times. Okay, 1 times 48 is 1. 2 times 24. 3 times 16. 4 times 12. 6 times 8. Wow. These are the numbers. Pairs of numbers that will multiply to get 48. Now, they say from these pairs, select the pair that contains the highest perfect square. Here we have a perfect square because of 1. We have a perfect square because of 16. We have a perfect square because of 4. Remember, a perfect square is a number whose square root is a whole number. So 4 is a perfect square, 16 is a perfect square, 1 is also a perfect square. So they said, from the pair, select the pair that contains the highest perfect square. Okay, which one contains the highest perfect square? That's this. So we are selecting this. So use the selected pair to replace the number in the surd. So we're going to use 3 times 16 to replace this. We're going to have 3 times 16. 3 times 16 is still 48. So we are just trying to write this in another form, not to change 48 so that it will no longer be 48. No, it's just to put it in another form, from non-basic form to a basic form. Remember, we are still dwelling on basic form. So by the time we come to the non-basic form, we'll now see how to do that. So we have replaced that. Separate them by multiplication. So we can write this as square root of 3 times square root of 16. Okay. Find the square root of the perfect square. So this is the perfect square. So I'll bring down this. Square root of 16 is what? 4. You now say use that square root to multiply the radical. So this is the radical. Now 4 times this will give me 4 root 3. I hope you know it will be totally unmathematical for you to just use this 4 to multiply 3 to have 12. No, you cannot do that. This is under a square root sign, so 4 cannot actually multiply this 3 because they are not in the same form. This is an ordinary number. This is a number that has a square root operation. So 4 cannot possibly multiply 3 inside that square root sign. So 4 times square root of 3 will give me 4 root 3. So square root of 16 is the same thing as 4 root 3. That's in basic form, in non-basic form. All right. So far, so good. I believe that these steps are becoming clearer to you. So we need to take another example. Let's take another example. Right, so let's say I have question 3. I have question 3 asked to express square root of 72 in basic form. So we have square root of 72. Take note of the sword. I know you have taken note of this, you have written these steps down. So, and they have become part of you. Yeah, they need to become part of you, so that anytime you see a problem that that is required, that you change a sword from non-basic form to basic form, you now know what to do, even without consulting your book. Okay? Take note of the sword. We have taken note of that sword 72, square root of 72. And list pairs of numbers that their product will give what? Give the number in the root sign. So, what are the numbers we multiply to get 72? I know we will not always use this, but let's just be listing them. 2 times 36, 3 times 24, 4 times 18, 6 times 12, 8 times 9. Wow. The product of all this will give us what? Will give us 72. Okay, they said one of the numbers in the pair must be the highest perfect square possible. So 1 is a perfect square, we have this. 36 is a perfect square, 4 is a perfect square, and 9 is also a perfect square. But we say the highest, the pair that contains the highest perfect square, and that pair is this man. This man. 36 is higher than other perfect square, that is bigger than this, bigger than this, bigger than 1. So we use the pair to replace. So we are going to have 2 times 36. Then separate them by multiplication. We have root 2 times root 36. Beautiful. Find the square root of the perfect square. So square root of 36 is actually what? 6. Then use that square root to multiply the radical. We have 6 root 2. So square root of 72 is the same thing as 6 root 2. Okay? So far so good. Alright, let's take one more problem. Then we'll go on a break. But before you go on a break, I have to give you a take-away question so that you will enjoy yourself with the take-away question. When we return, we'll now do justice to the take-away question. All right, let's take one more problem from our book on basic form of surd. So we have number 5. We're asked to express square root of 75 in basic form. Square root of 75. Okay? So we have taken note of that 75. 75. We have to take note of it. Let's do some mathematical gymnastics on it like we have done to others. So let's begin. Find the numbers you multiply to give you 75. 1 and 75. Which other one? 2 cannot divide that. 3 and 25. Which other one? 5 and 15. No other. So we have a perfect square here. We have a perfect square. Definitely 25 is larger than 1. So we are going to select this and use this to replace 75. So in alternative form, this should be 3 times 25. Okay, we separate them by multiplication. Square root of 3 times square root of 25. That's the perfect square, right? A perfect man, very perfect. All right, so square root of 25 is what? It's 5. So we use this to multiply that, and we have 5 with what? With 3. I believe you are enjoying this meal. Yeah, it's a very sweet meal. You are enjoying it. And because I can see you salivating, you are really enjoying the meal. All right, so far so good. Remember the steps that we have taken in order to arrive at our result. We need to take note of the number in the sort, find pairs of numbers that you multiply to give you the number in the sword. Then we go on to replace the number in the sword using one of the pairs, but there is a condition. The condition is that the selected pair must contain the highest perfect word, perfect square. And when we do that, we split the numbers using multiplication, then find the square root of the perfect square, and then use the square root of the perfect square to multiply the remaining radical, and then boom, we have our answer. All right, before I release you for the break, let's look at these takeaway questions quickly. Let's look at these takeaway questions. We need to take away these questions quickly. Just few questions that we need to take away. All right, so we say take away questions. Yeah, I may not want you to eat it in the class. Just take it away. Take it away and enjoy your meal. If anybody asks you what you are eating, tell the person you are enjoying mathematics meal. All right, express this salts in basic form. Express these salts in basic form. Okay, we have 1 square root of 54. 2, we have square root of 200. Okay, square root of 147, and then 4. We have square root of 288. All right, just these 4 questions. Express them in basic form. We shall be back, and when we come back, we look at the answers to these takeaway questions, and then we dwell a little on the non-basic form of sword. Then we can now continue with other objectives. Remember, we still have many other aspects of sword to look at: similar sword, addition and subtraction of sword, multiplication of sword, rationalization of denominators of fractions that are sword, then equality of sword, equations involving sword, and square root of sword. Just very massive, but I promise you, by the time we are done with all this, you will become a guru as far as sword is concerned. Yeah, you will receive power to trample upon all principalities and powers that are in sword, and no sword will by any means harm you. Thank you for following me to this point, and remain blessed. Remember, subscribe to our YouTube channel and follow us on Facebook. A meal a day is enough to cure mathematical diseases. Thank you, and God bless you.